é que é? Como é que é? Como é que é, maltinha? Está-se bem ou quê? Como é que é, como é que é, como é que é? Vamos lá. Ora, deixem-me só eu abrir aqui o Node.js. Node.js não. O VS Code. E vamos a isto. Ups. Ainda nem arrumei este aqui a tralha que eu tenho para aqui. Ok. Notificamos que era para aprender a fazer debug, basicamente pela consola em Node.js. Foi a última aula que tivemos, pelo menos. Epá, isto está muito alto. Só um bocadinho. E já está. Pronto. Deixa-me ver se está tudo bem. Não está, para este nível de luz. Está uma grande treta. Está uma grande treta mesmo. Bom. Deixa-me só fazer um bocadinho de spam já agora pelos discords e coisas assim do género. Mas podem falar que vou vendo. Ora. In my stream. Pronto, deixa lá ver. Pronto, já está. Então vamos lá, aqui ao nosso curso.
Through in the last video. Now we actually don't need to make any changes to our code. Things like debugger, those also work when we're debugging from the dev tools, exactly like they work when we're debugging from the command line. So we can kick things off right away by running a brand new command from the terminal. Now previously we used node inspect. That allowed us to debug via the command line. When we want to debug via the Chrome developer tools, we use node with a flag. It is the inspect-brk flag. This tells Node that we want to run in inspect mode, but we don't actually want to connect via the command line. So we don't want to see all that output, and we don't.
Ah, sério? Que fiz? Node inspect break.
Don't want to issue commands like N or C. We also want to break before that first line, just like we did last time. From here, we're going to type the things that you'd expect. We're just going to reference the file we want to run. playground/debugging.js. I'm going to run this, and you're going to notice that we only get 2 lines this time. And these are the exact same first 2 lines we got in the last video. The first one is letting us know that the debugger is up and running, and the second one is letting us know where we can learn more. But that third line is gone. If you remember, that third line told you successfully connected, followed by a bunch of output. We're not getting that here because we haven't connected yet. We're going to connect via Chrome. To do that, we're going to head over to the Chrome browser, and we're going to go to Chrome:///inspect. Now this Chrome protocol is where you can find all of those Chrome pages. So I could go to Chrome://version, for example. That'll bring me to the version page. You can go to the settings page. There's a whole bunch of them. We just need the inspect page. Now on this page, you should be seeing what I see here. Under remote target, you should have 1. Here it's my node version, as well as the file that's currently running. Now there's an inspect button below this, but you don't want to click that. We actually want to go to the Open Dedicated Dev Tools for Node link. Now if you're not seeing the remote target showing up, that is okay. We're just going to need to work through some configuration together. These tools are still new, and there are still a few edge cases depending on what operating system you're on and whether or not you have things like VPN or firewall settings. If you're not seeing this, just open up a question in the Q&A, and I promise we'll get to the bottom of it. If you are, then you can click this button, and it's going to bring us right into the dev tools. And what do we see here? We see the exact same file we saw in the last video. We have our wrapper function, we have all of the code we wrote, and we also have a whole bunch of other stuff. Now when it comes to debugging with Node, the only tab we're going to focus on is this Sources tab. The Console tab is also useful, but you can actually open up the console on the Sources tab using the Escape key. That's going to allow you to hide and show it. And the console is similar to REPL, where we can run JavaScript, like 1 + 4. Here we get 5. Awesome. Now on the left-hand side, we have a sources tree view. Under no domain, we have a bunch of files that aren't part of our application. Under file, we have some files that are, in this case, just one debugging.js, which happens to already be open. Now what we can do is go ahead and actually run through the app. So at this point, once again, we have paused before our app code has executed. So if I try to type person down below, we're going to get undefined. We can go ahead and run the program though using this big blue button. You can also note the keyboard shortcut there if you want to use that later. When we click the blue button, we're doing exactly what C did in the command line debugger. It is going to continue until the program ends or until we hit one of our breakpoints. We do have a breakpoint. Let's click that blue button and see what happens. Right here, we stop on line 7. Now, not only are we stopping on line 7, but we're getting some pretty cool output up above. We can see over here, we have some information about the arguments that got passed in. Down below, we have some information about what person looks like. So it's giving us a sneak peek into that data. So if I wanted to know what person equaled at this point in time, I could run person down below to get those properties back, or I could just view it right here in line. Now we can go ahead and continue on through the program, and there we are. We are done. Now there's no need to close this window. We can actually leave this one open, and the next time we run one of our Node apps in debug mode for the dev tools, it'll automatically refresh this guy. So let's go ahead and do that. Over inside of the terminal, I'm going to shut things down. We're going to reload the last command, but we're going to swap out Node for Node mon. So node mon can also be
Estou a usar, como é que é, Bester? Estás bom, meu?
flag, and that's going to do exactly what you might expect. It's going to
Estou a usar
restart the
porque é
debugger
mais
every time
simples
you change
agora
a file. Up above, we
fazer
would
isto.
not have had that same effect. We would have had to shut things down and restart them every time we change a file. But when we do run this with no mod, we're going to notice that right away we're brought inside of the debugger. We're paused on the very first line, and we can go ahead and continue through the program. I can click blue to get to our breakpoint. Now, aside from creating breakpoints with debugger, in the dev tools, you can actually click the line number to automatically create a breakpoint on the fly. So right now I have a breakpoint on line 5 and line 11. Now line 5 has come and gone, so that one is not going to get caught, but we haven't gotten to line 11 yet. So if I click that blue button, you can see that instead of continuing all the way through the end and printing out the object, we actually have stopped just before we print out the object. If I look at person, I can see that the person is indeed Mike. And if I click that blue play button, once again, it prints to the screen. Now there are still a few weird quirks. You'll notice that it printed out 4 times. There are things that are being worked through in the dev tools. Hopefully we're going to get some of these GitHub issues cleaned up really soon here. Now that we have all of this in place, we can switch back over to Atom and make a change. For example, I could change this to 26, save the file, and head back into the dev tools. Right away, we are running the new version of the application. I can continue through the program, use the new code, and make sure it's working as expected. So when I do my node debugging, I'm almost always doing it from Chrome developer tools. It is very useful to know that the command line tools exist. If you're on a server where you don't have access to things like installing Chrome, it is an essential tool in your tool belt. But for you right now, going through this course, I always recommend just using the Chrome dev tools. Now that we have this in place, we can head back into Atom. I'm going to revert that change, and we can move on to your challenge, which is once again going to be running the notes application and stopping at that breakpoint. I can shut things down over inside of the terminal and clear the output. Now, as I mentioned before, we can just leave this window open. There's no need to go through the Chrome and inspect URL and connect every single time. It'll automatically reconnect for us. We're going to go back into Atom and open up notes.js. So right here, remember, you added that debugger and you ran the application with the read command and a title argument. You're going to do the exact same thing, just pick a different note. So I'm going to go ahead and use this one right here, things to do. That's the note that I'll be searching for when I go through this challenge. Pick a note on your own, then run the application with the new flag.
É que é, gato, estás bom, meu?
Get to this point in the Chrome
Estou à procura da
developer
janela.
tools,
Está
print
aqui.
out note, and ensure that it looks correct. Once you're done, you can go ahead and click play. All right, how'd that one go? Hopefully you were able to get that done without too much trouble. We're going to go ahead and knock things out. First off, by running the command. No need for a code change. I'm going to run nodemon, though node would work as well. Inspect-brk, then the application app.js. We want to use the read command, and we want to read a note with a specific title. In our case, I picked one. I believe it was called Things to Do. Awesome. Now at this point, we're brought over into the Chrome developer tools, and you can see that there is a ton of application code inside a file. We now have app.js, and if I click play, you can see that the other files come into play as they're used. Now we have Node.js. We're stopped at that point where we put our debugger, and we can actually see that the object is correct by looking at this little inline note that the Chrome Dev Tools has added for us. We could also go ahead and just type note down below, and we are indeed getting quite a few copies of that. So we're going to work on fixing that one. Hopefully they do get a fix. For now, though, at least it's the same thing multiple times, and it's still easy to figure out what's happening. Now that we've done that, we could always change something. This wasn't part of the challenge, but you could set note.body equal to something else. We can run that. I can click play, and when the program ends, the new body value is indeed that is showing up. So there we have it. We now have 2 tools we can use to debug our applications. We can use the command line interface if we must, and when we're debugging our applications, what I'd suggest you do is you use the Chrome developer tools. If you ever forget how any of that works, just come back and check these videos out. Debugging is one of those skills that is really, really tedious and slow at first. It's going to take quite a bit of time before you really get comfortable with that flow, but I promise that every issue you debug gets you moving a little bit faster. And before you know it, you're going to be moving through bugs really, really quickly. I'm going to remove the debugger.js, save the file. For this one, I will see you next time.
Certo.
And now that we've made some awesome progress on debugging, let's go back to the commands for our app, because there is only one more to fill out. It's the list command. And it's going to be really, really easy. There is nothing complex going on here. In order to get started, all we need to do is fill out the list notes function, which in this case we called getAll. GetAll is responsible for returning every single note. That means it's going to return an array of objects, an array of all of our notes. All we have to do that is return fetch notes. There's no need to filter, there's no need to manipulate the data. We just need to pass the data from fetch notes back through getAll. Now that we have this in place, we can fill out the functionality over inside of app.js. We have to create a variable where we can store the notes. I was going to call it notes, but I probably shouldn't because we already have a notes variable declared. I'm going to create a variable called all notes, setting it equal to the return value from getAll, which, as we know, because we just filled out, returns all the notes. Now I can use console.log to print a little message, console.log, and I'm going to use template strings so I can inject the actual number of notes that are going to be printed. Right here, I'm going to say printing, then the number of notes using the $sign and the curly braces, all notes dot length, that's the length of the array, followed by notes with the S in parentheses to handle both singular and plural cases. So if there were 6 notes, it would say printing 6 notes. Now that we have this in place, we have to go about the process of actually printing each note, which means we need to call log note once for every item in the all notes array. To do this, we're going to use for each, which is an array method similar to filter. Filter lets you manipulate the array by returning true or false to keep items or remove items. For each simply calls a callback function once for each item in the array. In this case, we can use it using all notes dot for each, passing in a callback function. Now that callback function is going to be an arrow function in our case, and it's going to get called with the note variable just like filter would have. And all we're going to do is call notes dot log note, passing in the note argument, which is right here. And now that we have this in place, we can actually simplify it, taking the log note call, removing the curly braces, and pasting it right here. This is the exact same functionality, only using the expression syntax. Now that we have our arrow function in place, we are calling notes.log note once for each item in the all notes array. Let's go ahead and save the app.js file and test this out over in the terminal. In order to test out the list command, all I'm going to do is use node app.js with the command list. There is no need to pass in any arguments. When I run this, I do get printing 3 notes, and then I get my 3 notes: to buy from store, and things to do, which is fantastic. With this in place, all of our commands are now working. We can add notes, we can remove notes, we can read an individual note, and we can list all of the notes stored in our JSON file. With this in place, I also want to clean up some of these commands up above. We have some console log statements that are printing out a few things we no longer need. At the very top of app.js, I am going to remove the starting app.js console log statement, making the constant fs the first line. I'm also going to remove the 2 statements right here that print the command and the yards variable value. I'm also, inside of notes.js, going to remove the console log statement at the very top of that file, since it's no longer necessary. It was definitely useful when we first started exploring different files, but now we have everything in place and there's no need. If I rerun the list command, this time you can see it looks a lot cleaner. Printing 3 notes is the very first line showing up. With this in place, we are done our commands, but there is still one thing I want to do. In the next video, we're going to take a slightly more in-depth look at how we can configure yards. This is going to let us require certain arguments for our commands. So if someone tries to add a note without a title, we can warn the user and prevent the program from executing. I'll see you next time.
Estou a ver. Require an arguments and advanced yards. Okay. The fuck?
In this video, you are going to learn a little bit more about how we can configure yargs for these command line interface applications. We're going to learn how to set up the commands, their descriptions, and the arguments. We'll be able to set various properties on the arguments, like whether or not they're required and others. Now, before we get into any of that, I do want to pull up the yargs docs so you at least know where this information is coming from. You can get it by Googling npm yargs. We're going to go to the first page, which is the yargs package page on npm. This has the documentation for yargs. Now, there is no table of contents for the yargs docs, which makes it kind of difficult to navigate. It starts off with some examples that don't go in any particular order, and then eventually it gets into a list of all the methods you have available, and that's what we're looking for. So I'm going to use Command F to search the page for methods. And right here, we get the methods header. This is the one we're looking for. If you scroll down just a little bit, we start to see an alphabetical list of all the methods you have access to inside of yargs. And we're looking for .command. This is the method we can use to configure all 4 of our commands. We're going to specify which options they require, if any, and we can also set up things like descriptions and help functionality. Now, in order to get started, we're going to pull up the terminal, obviously, and the Atom editor, and all we need to do is make some changes inside of app.js. This is exactly where we're going to get started. And we're going to start with that add command. We want to add a few helpful method we can use to configure all 4 of our command. And right here, we get the methods header. This is the one we're looking for. If you scroll,
estás a ter a queda de frames? Não. Acho que não. Não sei. Mas acho que não. Nem sei porque é que eu estou a ter a queda. Se eu tiver. Se calhar estou a ter alguma. 42%. Isso é bué. Fosca-se. Não entendo porquê. Não faço a mínima. Bom. Não estou a encontrar aquilo que ele está a falar. Ele está a falar disto. Certo. Vai.
scroll down just a little bit, we start to see an alphabetical list of all the methods you have access to inside of yargs. And we're looking for .command. This is the method we can use to configure all 4 of our commands. We're going to specify which options they require, if any, and we can also set up things like descriptions and help functionality. Now, in order to get started, we're going to pull up the terminal, obviously, and the Atom editor, and all we need to do is make some changes inside of app.js. This is exactly where we're going to get started. And we're going to start with that add command. We want to add a few helpful pieces of information in here that's going to, 1, let yargs verify the add command is ran appropriately, and 2, let the user know how the add command is meant to be executed. Now, we are going to be chaining property calls, which means right before I access .argv, I want to call .command, and then I'm going to call .argv on the return value from command. Now, this syntax probably looks familiar, this chaining syntax, if you've used something like jQuery. A lot of different libraries support it. Anyways, once we call .command on yargs, we're going to pass in 3 arguments. The first one is the command name, exactly how the user is going to type it in the terminal. In our case, it's going to be add. Then we're going to pass another string in, and this is going to be a description of what the command does. Some sort of English readable description that a user can read to figure out if that's the command they want to run. Add
vai indo, pá.
node.
Add a new node.
The next one is going to be an object. This is going to be the options object that lets us specify what arguments this command requires. Now, before we get into the options object, let's go ahead and add one more call right after command. We're going to call .help, which is a method, so we're going to call it as a function, and we don't need to pass in any arguments. When we add on this help call, it sets up yargs to return some really useful information when someone runs the program. For example, I can run node app.js with the help flag. The help flag is added because we called that help method. And when I run the program, you can see all of the options we have available. We have one command, add a new note, and we have a help option for the current command, which is nothing, it's just help. And the same thing holds true if we do node app.js add with help. Here we can view all of the arguments for add, which in this case happens to be none.
Estou a curtir, sim senhora, estou a vê-lo com breaks. Epá, faz refresh, man.
In order to add properties, we're going to update this options object, where the key is the property name, whether it's title or body, and the value is another object that lets us specify how that property should work. So in the case of title, we would add title on the left, and we would put our options object on the right.
Porquê que vocês estão a ver com breaks? Isso é estranho, man. Pá, não fiz nada demais hoje e nos outros dias também não faço nada demais. Não percebo, meu. Honestamente não consigo perceber. Deixa lá ver se isto ajuda. Se calhar ajuda, Pedro. Espera lá. Tenho aqui coisas abertas que não estou a precisar, portanto posso fechá-las. A ver se ajuda. Será que ajudou? Acho que é a Twitch. Epá, pois, não sei o que é. Os frames são exatamente a mesma merda, mano. É que eu estou a ver pelo OBS, estás a ver? E mesmo pelo OBS está-me a dizer que eu tenho 41%. Tipo, é bué. Foda-se. Mas já. Agora é que eu estou a ver que tenho bué. Espera lá. Pois tenho. Foda-se. Isto é outra merda, meu. Como é que eu sei se é da Twitch ou se é meu ou se é o Recuparta? Isto é alta merda, pá. Porque eu não sei como é que é de resolver isto. Olha, vou continuar.
Inside of here, we're going to configure 3 properties. Describe. Let's do that one first. It's super simple. Describe. Describe is going to get set equal to a string, and this is going to describe what is supposed to be passed in for the title. In this case, we can just use title of note. Awesome. Now, after describe is in place, we can go ahead and configure demand. Demand is going to tell Yarg whether or not this argument is required. Demand is false by default. We're going to go ahead and set it to true. Demand, true. Now, if someone tries to run the add command without the title, it's going to fail. And we can prove this. We can save app.js, and over in the terminal, we can rerun our previous command, removing the help flag. And when I do that, you see we get a warning. Missing required argument title. Right here, you see the title argument. We have title of note, which is the describe string we used.
Nos outros canais também dá igual. A mim só me dá no do Pedro. Pois, great shit, man. Mas a mim está. Mas eu tenho aqui com 44% de drops, pá, portanto. Bem, deixem-me ver se é aqui uma cena que eu estou aqui a pensar que seja, provavelmente é. Epá, pois eu estou aqui a ver pessoal que não tem metade dos drops que eu tenho. Espera aí. Olha aqui, se calhar até tem, deixa-me lá ver. Só vou ver aqui um caso. Pois. É o meu caso, é. Esperem lá. Eu vou abaixo e já venho. Não é preciso saírem. Esperem lá, deixem-me ver. Venho já, pessoal. Back. Vamos lá ver se isto está a dar. Acho que agora já está a bombar. Acho. Nossa, deixa eu ver se estava um baiting. Agora acho que já está. Tá. Sim. Não consigo perceber muito bem se está ou não. Veja lá se está fixe, pessoal, agora. Vamos ver várias vezes, tal. Ver aqui. Telefone. Segundo o que tenho aqui, já não tenho drop frames, quero. Não sei, não faço a mínima. A mim, no meu caso, está a parar várias vezes. Não sei, pá, já não faço a mínima. Bom, tenho que aprender isto. Vamos lá. Portanto, se eu fizer nodes app.js help mostra ajuda. Ok. Head. Falta argumento obrigatório. Title. Isto mete em inglês, em português. Okay.
And it's required on the right, letting you know that you have to provide a title when you're calling that add command. Now, along with describe and demand, we are going to be providing a third option. This is called alias. Alias lets us provide a shortcut, so you don't have to type --title. You can set the alias equal to a single character like T. When you do that, you can now run the command in the terminal using the new syntax. Let's go ahead and run our add command. Node app.js add. Instead of --title, we're going to use -title, which is the flag version. And we can set that equal to whatever we like. Flag title will be the title, and --body will get set equal to body. We haven't set up the body argument yet, so there is no alias, but if I run this command, everything works as expected.
Ah, 24. qual é, o que está errado? Oh. Se calhar era isto. Parvo isso, pá. Por mim agora está fixe a merda da net agora. Pois, deve estar a precisar de um reboot ao PC. Também pode ser, sim, que há muito tempo que não dou um reboot. Há muito tempo mesmo. 5. Bom.
The flag title shows up right where it should, even though we use the alias version, which is the letter T. And now that we have our title configured, we can do the exact same thing for body. We're going to specify our options object right here, and we can provide those 3 arguments. What I would like you to do is set up describe, demand, and alias for body. Set describe equal to whatever you like, something like the body of the note. Set demand equal to true, and set the alias equal to the letter B. Then, over in the terminal, run the help command to make sure that the body shows up, like title did right here. Then go ahead and run add with
assim é
the
gozar
body
com a cara do
argument,
pobre.
but use the shortcut version, the B flag.
Podes
Take a
crer,
moment to
pá.
knock that out,
Podes crer.
run the commands from the terminal, and when you're done, go ahead and click play.
Já está. Está feito.
How'd it go? Hopefully you didn't have too much trouble getting those 3 options set up. The first one is describe, and that one's pretty easy. Describe is going to get set equal to a string, and in this case, body of note will get the job done. Next step is going to be demand, and to add a note, we are going to need a body. So we're going to set demand equal to true, just like we do up above for title. And last but not least is the alias. The alias is going to get set equal to a single letter. I'm going to use the letter B for body. With this in place, we
Olha,
can
agora
now
disto não
save
tenho views.
app.js, and over inside of the terminal, we can take a moment to rerun node app.js add with the help flag. When we run this command, we should now see the body argument showing up. And you can even see it shows the flag version right here, the alias -b. Body of note, and it is required. Everything looks great. Now, I'm going to go ahead and run add node app.js add, passing in 2 arguments, T. I'm going to set that equal to T, and B, setting it equal to B. When I run the command, everything works as expected. A new note was created with a title of T and a body of B. With this in place, we've now successfully completed the setup for the add command. We have our add command title, we have a description, and we have the block that specifies the arguments for that command. Now we do have 3 more commands to add support for, so let's go ahead and get started doing that. On the next line, I'm going to call .command again, passing in the command name. Let's go ahead and do the list command first, because that one's really easy. No arguments are required. Then we're going to pass in the description for the list command, list all notes. Excellent. Next up, we're going to call command again. This time, we'll do the command for read. Read reads an individual note, so for the description or the read command, we'll use something like read a note. Now, the read command does require the title argument. That means we are going to need to provide that options object. And I'm going to take title from up above, copy it, and paste it below. Now, as you probably just noticed, we have repeated code. The title configuration just got copy and pasted into multiple places. It would be pretty nice if this was dry. If it was in one variable, we could reference in both locations, right here and right here. Now, this is going to be your challenge for the video. What I want you to do is fill out the remove command call to command. That means you're going to set up remove, the description, and the options. It only requires the title, so the options are going to look identical to what we have here for read. Then what I'd like you to do is pull the body object, what I have highlighted right here, and the title object right here into separate variables that get defined up above. And you can reference title options and body options inside of the command arguments. Right here, you would put title options like this. And right here, you would put body options. Now I'm going to undo that so we have the working code in place.
Okay. Title options.
You can do the same thing for read. Read only has the title, so you only need to reference the title options variable, and remove, which you're going to add, only uses the title as well, so you just need to add the title, setting it equal to title option.
Twitch, estamos aqui, olá. Atualiza. Atualiza o quê? Desculpa. Sou eu que atualizo ou é Twitch? Te caga na Twitch, pá. O que é importante é a gente falar e manter o contato. Isso é que é fixe. Eu estou aqui a fazer basicamente o curso. Para quem não sabe. Ok. Remove, né? Remove, yeah. Remove a node. Title options, pronto. Também estou a reutilizar, não estou a reutilizar o código aqui, mas...
These other commands, we've actually gotten access to more help features. If I run node app.js with help, you can see our other commands have shown up. So once you're done with the challenge, make sure remove shows up here as well. Then try to remove a note. Use the alias for title and use the regular version for title, which is -- title, making sure everything still works as expected. Take some time to knock that out. That means you're going to call command for remove, set up its arguments, and then you're going to move these objects 1, 2, 3, and the fourth one that you're going to create that can get referenced everywhere they're required. All right, pause the video, knock that out, and when you're done, click play. How'd you do? I know I left this one a little open-ended, but that's the goal of these challenges. As the course progresses, I want
Estou super contente por ter arranjado espaço para o meetup. Ainda bem, man. Isso é ótimo para ti, meu. Esse espaço é fixe, a Mindera é fixe.
I'll call a command again, this time for remove. Now the remove command is going to have a description. We'll stick with something simple like remove a note. And we are going to be providing a options object. And in that options object, I'm going to set title equal to title options. Now I don't have title options created yet, so the code would currently fail, but this is the general idea. We want to create the title options object once and reference it in all the locations we use it. I can take title options and add it here for read, title options, and up above for add, I can cut out the object, putting it in the clipboard, and I can replace it with title options. Now up above, I can create a constant called title options, and I can set it equal to that object that I just cut out to the clipboard. Right here, we now have the title options in place. And this is going to work as expected. We have the exact same functionality we did before, but we now have the title options in a separate object. Now we could also do the same.
Só deve ser para este meetup. Fala com eles. Provavelmente não. Vê com eles, pá. Se calhar tens uma surpresa ainda vais ver. Options.
Now, up above, I can create that constant body options. setting it equal to the object I just cut out. And with this in place, we are now done. We have add, read, and remove all with their arguments set up, referencing the variables defined up above. With this in place, let's go ahead and test out that remove command. I'm going to list out my notes using Node app.js list so I can see which notes I have to remove. I'm going to go ahead and remove the note with the title of flag title and the note with the title of t using Node app.js remove. Let's go ahead and use our flag first, t. We're going to remove the note with a title of t. And there we go. Note was removed, prints to the screen. And if I use the up arrow key twice, I can list the notes out again, and you can see the note with the title of t is indeed gone. Let's go ahead and remove one more note using Node app.js remove. This time we're going to use -- title, which is the argument name, and the note we're going to remove has a title of flag title. When I remove it, it says note was removed, and if I rerun the list command, I can see that we have 3 notes left. The note was indeed removed. And that is it for the notes application. In this application, we learned a lot of new things. We learned how to create command line tools. We learned how to use third-party modules, how to use global modules, and how to create our own files like notes.js that have functions we can use inside of our application. We also took a look at how we can access the file system, which is exactly what we did with our notes data.json file. Here we used a couple functions to encode our JSON data, save it in a file, and then read it out when someone reran the command. That let us store data in the file system, and when I run a command like node app.js list, fetch that data back. That is the end of this video, and it is the end of the Notes application. The Notes app is a great start. We learned the basics of Node, but now it's time to learn more about asynchronous programming and how we can fetch data from third-party APIs. That is the big topic of the next section. I'll see you in the next video where we're going to go over arrow functions in more detail. It's still going to be part of the Notes application, although we won't be updating the app itself. We're going to work in the playground folder to explore how arrow functions are different from the regular ES5 functions you're probably used to. Stay tuned, I will see you then.
Este gajo explica muito bem, man. Caso curto bastante.
In this video, you're going to learn the ins and outs of the arrow function. It's an ES6
Gosto bastante deste
We
gajo.
have taken a little look at it. Inside of notes.js, we used it in a few basic examples to create methods like fetch notes and save notes, and we also passed it into a few array methods like filter right here and for each. We used it as the callback function that gets called once for every item in the array. Now, if you try to swap out all of the functions in a program with arrow functions, it's most likely not going to work as expected because there are some differences between the two. And it's really important to know what those differences are so you can make the decision to use a regular ES5 function or to use an ES6 arrow function. The goal in this video is to give you the knowledge to make that choice. And we're going to kick things off by creating a new file in the playground folder called arrow-function.js. Inside of here, we're going to play around with a few examples, going over some of the subtleties to the arrow function. Before we type anything inside of the file, I'm going to start up this file with nodemon, so every time we make a change, it automatically refreshes over in the terminal. If you remember, nodemon is that utility we installed earlier in this section. It was a global npm module. Nodemon is the command to run, and then we just pass in the file path like we would for any other node command. Here we're going into the playground folder, and the file itself is called arrow-function.js. We're going to run the file, and nothing prints to the screen besides the nodemon logs because we have nothing in the file. To get started, we're going to create a function called square by making a variable called square and setting it equal to an arrow function. To make our arrow function, we're going to first provide the arguments inside of parentheses. Since we're going to be squaring a number, we just need one number, and I'm going to refer to that number as x. If I pass in 3, I should expect 9 back, and if I pass in 9, I would expect 81 back. After the arguments list, we have to put the arrow in arrow function by putting the sign and the greater than symbol together, creating our nice little arrow. From here, we can go ahead and provide inside of curly braces all of the statements we want to execute. We might go ahead and create a variable called result, setting that equal to x times x.
Then we might return the result variable using the return keyword. Now obviously this can be done on one line, but the goal here is to illustrate that when you use the statement arrow function, you can put as many lines as you want in between those curly braces. Let's go ahead and call square. We're going to do that using console.log so we can print the result to the screen. Console.log right here. I'm going to call square, and we're going to call square with 9. The square of 9 would be 81, so we would expect 81.
Shit.
I'm going to save the arrow function file, and over here in the terminal, 81 shows up just like we expect. Now this is the statement syntax for the arrow function. We've also explored the expression syntax, which lets you simplify your arrow functions when you're just going to be returning some expression. In this case, all we need to do is specify the expression we want to return. In our case, that's x times x. You don't need to explicitly add the return keyword. When you use an arrow function without your curly braces, it's implicitly provided for you. That means we can save the function just like this, and the exact same result is going to print to the screen. 81 shows up. This is one of the great advantages of arrow functions. When you're using them in cases like filter or for each, which we did in the Node.js file, it lets you simplify your code, keeping everything on one line and making your code a lot easier to maintain and scan. Now there is one thing I want to note. When you have an arrow function that has just one argument, you can actually leave off the parentheses. If you have 2 or more arguments, or you have 0 arguments like this, you are going to need to provide the parentheses. But if you just have 1, you can reference it like this with no parentheses. If I save the file in this state, 81 still prints to the screen. And this is great. We have an even simpler version of our arrow function. Now that we have a basic example down, I want to move on to a more complex example that's going to explore the nuances between regular functions and arrow functions. To illustrate this, I'm going to make a variable called user, which is going to be an object. On this object, we're going to specify one property name. Go ahead and set name equal to the string, your name. In this case, I'm going to set it equal to the string Andrew. Then we can go ahead and define a method on the user object. Right after name, with my comma at the end of the line, I'm going to provide the method say hi, setting it equal to an arrow function that doesn't take any arguments. For the moment, we'll keep the arrow function really simple. All we're going to do inside of say hi is use console.log to print to the screen inside of template strings hi. We're not using template strings yet, but we will in a second, so I'm going to use them here. Down below, we can test out say hi by calling it user.sayHi. I'm going to go ahead and call it, then save the file, and we would expect that hi prints to the screen, because all our arrow function does is use console.log to print a static string. Nothing here is going to cause any problems. You'd be able to swap out a regular function for an arrow function without issue. Now, the first issue that's going to arise when you're using arrow functions is the fact that arrow functions do not bind a this keyword. So if you are using this inside of your function, it's not going to work when you swap it out for an arrow function. The this binding refers to the parent binding. In this case, there is no parent function, so this would refer to the global this keyword. Now here we have our console.log that does not use this. I'm going to swap it out for a case that does. We're going to put a period after hi, and I'll say I'm followed by the name, which we would usually be able to access via this.name. If I try to run this code, it is not going to work as expected. We're going to get hi, I'm undefined, printing to the screen, which is exactly what we have. In order to fix this, we're going to look at an alternative syntax to arrow functions that's great when you're defining object literals like we are right here. After say hi, I'm going to make a new method called say hi alt using a different ES6 feature. ES6 provides us a new way to make methods on objects. You provide the method name, say hi alt, then you go right to the parentheses, skipping the colon. There's also no need for the function keyword, even though it is a regular function. It's not an arrow function. Then we move on to our curly braces. Inside of here, I can have the exact same code we have above, but it is going to work as expected. It's going to print, hi, I'm Andrew. I'm going to call say hi alt down below instead of the regular say hi method, and right here you can see hi, I'm Andrew prints to the screen. This is a syntax that you can use to solve this problem when you're creating functions on object literals like we are here. Now that we know that the this keyword does not get bound, let's go ahead and explore one other quirk that arrow functions have. It also does not bind that arguments array. Regular functions, like the one we have here, are going to have an arguments array that's accessible inside of the function. Console.log arguments. Now it's not an actual array, it's more like an object with array-like properties. You can Google that for more information. But the arguments object is indeed specified in a regular function. If I pass in 1, 2, and 3, and save the file, we're going to get that back when we log out arguments. Over inside of NodeMon, it's taking a quick second to restart. And right here, we have our object. We have 1, 2, and 3. We have the index for each as the property name. And this works because we're using a regular function. If we were to switch to the arrow function, though, it is not going to work as expected. I'm going to add console.log arguments inside of my arrow function, and I'm going to switch from calling sayHiAlt back to the original method sayHi. When I save the file here, we're going to get something a lot different than what we had before. What we're actually getting is the global arguments variable. This is the arguments variable for that wrapper function we explored. Here we have things like the require function definition, our modules object, and a couple string paths to the file and to the current directory. These are obviously not what we're expecting. And that is another thing that you have to be aware of when you're using arrow functions. You're not going to get that arguments keyword. You're not going to get that this binding that you'd expect. These problems mostly arise when you try to create methods on an object and use arrow functions. I would highly recommend switching to this syntax in those cases. You get a simplified syntax, but you also get the this binding, and you get your arguments variable like you'd expect. That is it for this video. You've explored a little bit more about arrow functions, how they work, when to use them, and when not to use them. In general, if you don't need the this keyword or the arguments keyword, you can use an arrow function without problem. And I always prefer using arrow functions over regular functions when I can. Now in the next section, when we explore asynchronous programming, we're going to use both regular functions and arrow functions a lot more, and you'll be able to see firsthand how to choose between one over the other. That's coming up in the next section, so stay tuned. I am super excited to get to it. I'll see you soon.
Tá fixe.
Hello and welcome to Section 4, Asynchronous Node.js. Now, if you've read just one article about Node, you've probably come across 4 terms: asynchronous, non-blocking, event-based, and single-threaded. All of those are accurate terms to describe Node. The problem is it usually stops there. It's really abstract. The goal in this section is to make that super practical by putting it all to use in our weather application. That's the project we're going to be building in this section, and to get it done, we're going to need to make asynchronous HTTP requests. We're going to want to fetch from 2 APIs. We'll be using Google's geolocation API, and we'll be using the dark sky API to take location information, like a zip code, and turn that into real-world current weather information. Now, in order to do all that, we're going to look at callbacks, promises, HTTP requests, and more. Let's go ahead and dive right in, though, looking at the very basics of async programming in Node.
Certo.
In this video, you're going to create your first asynchronous non-blocking program, which means your app is going to
Entendes e decoraste tudo? Não decorei nada. Entendes? Há coisas que eu já sei fazer. Não são muito diferentes.
A weather app that communicates with third-party APIs like the Google API and a weather API. We're going to need to use asynchronous code to fetch data from those sources. Before we get into any of that, though, in this video, we're going to go over a basic example of asynchronous programming, and in the next one, we're going to talk about what happens behind the scenes when you run asynchronous code. That video, coming up next, will give you a really good idea about how your program runs, what tools and tricks are happening behind the scenes to make it run the way it does. For now, though, all we need to do is make a new folder on the desktop for this section. I'm going to navigate onto my desktop and use mkdir to make a new directory, and I'm going to call this one weather-app. All I need to do before I switch to Atom is navigate into the weather app. Perfect, and I'm going to use clear to clear the terminal output.
Certo.
Now we can
Peraí. Olha, vou pôr isto para o fricô de campo. Já que estou aqui a perder tempo nisto. Perder tempo não, que eu estou a aprender. Alguma coisa sempre. Sai. Tchau, boa noite, Bester. Muito obrigado por ter estado aí, pá. Close editor. Scanner close folder. Isso. E vou aqui ao desktop. Onde é que está? Está aqui. Pronto.
open up that new weather app directory inside of Atom. This is the directory we'll be using throughout this entire section. In this video, we're not going to be building out the weather app just yet. We're going to be playing around with the async features. So inside of weather app, I want you to make that playground folder. This code is not going to be part of the weather app, but it will be really useful when it comes to creating the weather app in a couple videos. Now, inside of playground, we can go ahead and make the file for this video, async-basics.js. Awesome. I'm going to close this untitled tab and we can get started. To illustrate how the asynchronous programming model works, we're going to get started with a really basic example.
Estou a fazer exercício, Diogo. Como é que é? Estás bom,
Let's get
pá?
started by adding a couple console.log statements in a synchronous way. Nothing new here. We're going to create one at the beginning of the app that's going to say starting app. And we
Acho
can
que a
add a
gente está
second
chato
one
com
to the
isto.
end. Down below,
Starting.
console.log, and this one will print finishing up. Awesome. Now these are always going to run synchronously. No matter how many times you run the program, starting app is always going to show up before finishing app. In order to add some asynchronous code, we're going to take a look at a function that Node provides called setTimeout. Set, capital T, timeout. SetTimeout is a great method for illustrating the basics of non-blocking programming. It takes two arguments. The first one is a function. This is going to be referred to as a callback function. It's going to get fired after a certain amount of time. And that's the second argument. It's a number, the number of milliseconds you want to wait. So if you want to wait 1 second, you would pass in 1,000 milliseconds. Let's go ahead and call setTimeout, passing in an arrow function as our first argument. This is going to be the callback function. It's not going to get fired right away. It's going to get fired after the timeout is up, after our 2 seconds. And then we can set up our second argument, which is the delay, 2,000 milliseconds, which equals those 2 seconds. Inside of here, all we're going to do is use a console.log so we can figure out exactly when this function fires, because the statement will print to the screen. Console.log, and something like inside of callback will get the job done. Inside of callback. Awesome. Now with this in place, we're actually ready to run our very first async program. And I'm not going to use NodeMon to execute it. I'll show you why in just a second. I'm going to run this file from the terminal using the basic node command.
Já não lembro como é que se mostra o editor aqui no VS Code. Como é que era? Pronto. Nome do comando. Não me lembro. Não, pera. Já fizeste este curso, né? E toma.
Node, space, playground, and the file inside the playground folder is async-basics.js. Now pay close attention to exactly what happens when I hit enter. Right away, 2 messages show up, then 2 seconds later, our final message inside of callback prints to the screen. Right away, we got starting app. Basically, immediately after that, finishing up prints to the screen, finally inside of callback. Over here inside of the file, this is not the order we wrote the code, but it is the order the code executes in. Starting app prints to the screen as you expected. Down here, we call setTimeout. but we're not actually telling it to wait 2 seconds. We're registering a callback that's going to get fired in 2 seconds. This is going to be an asynchronous callback, which means that Node can do other things while these 2 seconds are happening. In this case, the other thing it does is it moves down to finishing up. Now, since we did register this callback by using setTimeout, it is going to fire at some point in time, and 2 seconds later, we do indeed see inside of callback printing to the screen. Hopefully, this makes a little bit of sense. By using non-blocking I/O, we're able to wait, in this case 2 seconds, without preventing the rest of the program from executing. If this was blocking, we would have to wait 2 seconds for this code to fire, then finishing up would print to the screen. And obviously that would not be ideal. Now obviously this is a pretty contrived example. We're not exactly going to be using setTimeout in our real world apps to create unnecessary arbitrary delays, but the principles are the same. For example, when we fetch data from the Google API, we're going to need to wait about 100 to 200 milliseconds for that data to come back. And we don't want the rest of the program to just be idle. It's going to continue on. We're going to register a callback, and that callback is going to get fired once the data comes back from the Google servers. The same principles apply, even though what's actually happening is quite different. Now, in order to wrap this video up, I want you to write another setTimeout right here on line 7. I want you to register a setTimeout that prints a message, something like second setTimeout works. That's going to be inside the callback. And I want you to register a delay of 0 milliseconds. 0. No delay at all. Then go ahead and run the program from the terminal and see exactly what happens. How'd it go? Hopefully you were able to run the program and maybe you saw something that didn't quite make sense. Let's go ahead and fill out the async basics setTimeout. I'm going to call setTimeout with my arrow function, passing in a delay of 0 milliseconds. Awesome. Inside of here, I'm going to use console.log so I can see exactly when this function executes, and I'm going to use second setTimeout as the text. Now that we have this in place, we can go ahead and run the program over from the terminal. And it's really important to pay attention to the order the statements print. I'm going to run the program. Right away, we get 3 statements, and then at the very end, 2 seconds later, we get our final statement. We start with starting out, which makes sense. It's at the top. Then we get finishing up. After finishing up, we get second setTimeout, which seems weird because we clearly told Node, hey, we want to run this function after 0 milliseconds, which should run it right away. But in our example, second setTimeout printed after finishing up. Finally, inside of callback printed to the screen. This behavior is completely expected. This is exactly how Node.js is supposed to operate. And it's going to become a lot clearer after the next video where I go through this example exactly, showing you what happens behind the scenes. We're going to get started with a more basic example, showing you how the call stack works. We'll talk all about that in the next video. And then we're going to go on to a more complex example like this one.
O gajo enrola muito, pá. Mas há coisas que é, pronto, isto é, se calhar é necessário.
The reason why second setTimeout comes up after finishing up is going to be very obvious after the next video. I'm super excited to get to it, so stay tuned. I will see you then.
Vai, continua. Sim.
In the last video...
Antes de começar este, vou fumar um cigarrinho, maltinha. Vem já, tá bem? Até já. Onde é que está? Está aqui. Até já.
you ended up creating your very first asynchronous application.
Epá, esqueci-me de pôr isto online. Como é que é? Voltei. Vamos lá.
But unfortunately, we ended up asking more questions than we got answers to. We don't exactly know how async programming works, even though we've used it. My goal for you in this video is to understand why the program runs the way it does. For example, why does this 2-second delay not prevent the rest of the app from running? And why does a 0-second delay cause the function to be executed after finishing up prints to the screen? These are all questions we're going to answer in this video. This video is going to take you behind the scenes into what happens in V8 and Node when an async program runs. It's a little complex, which is why I recommend multiple viewings. I would watch it once now, I'd work through the weather app, and then I would watch it once again. When you come back to it after having played around with a lot of async programming, it's going to make a lot more sense. Now let's dive right into how this program runs. We're going to start with the basic example, then we'll move on to figuring out exactly what happens here. Here is example number 1. On the left, we have the code, in this case, a really basic synchronous example. And on the right, we have everything that happens behind the scenes. The call stack, our Node APIs, the callback queue, and the event loop. Now, if you've ever read an article or watched another video on how Node works, you've most likely heard about one or more of these. In this video, we're going to be exploring how they all fit together to create a real-world working Node application. Now for our example here, the first one, the synchronous one, all we need to worry about is the call stack. The call stack is part of V8, and for our synchronous example, it's the only thing that's going to run. We're not using any Node APIs, and we're not doing any asynchronous programming. The call stack is a really simple data structure that keeps track of program execution inside of V8. It keeps track of the functions currently executing and the statements that are fired. The call stack is a really simple data structure that can do two things. One, you can add something on the top of it, and two, you can remove the top item. That is all it can do. That means if there's an item right here and there's an item above it, you can't remove the bottom item, you have to remove the top item. If there's already two items and you want to add something onto it, it has to go on the top, because that's how the call stack works. Think about it like a can of Pringles or a thing of tennis balls. If there's already an item in there and you drop one in, the item you just dropped in, it's not going to be the bottom item, it's going to be the top item. And you can't remove the bottom tennis ball from a can of tennis balls, you have to remove the one on top first. That's exactly how the call stack works. Now when we start executing this program, the first thing that happens is Node runs the main function. The main function is that wrapper function we saw over in NodeMon that gets wrapped around all of our files when we run them through Node. In this case, by telling V8 to run the main function, we are starting the program. The first thing we do in the program is we create a variable x, setting it equal to 1. And that's the first statement that's going to run. Notice it comes in on top of main. Now this statement's going to run, creating the variable. Once it's done, we can remove it and move on to the next statement, where we make the variable y, which gets set equal to x, which is 1, plus 9. That means y is going to be equal to 10. Right here, we do that, and we move on to the next line. The next line is our console.log statement. Console.log is going to print y is 10 to the screen. We use template strings to inject the y variable right here. When we run this line, it gets popped on to the call stack, and once it's done, it gets removed. At this point, we've executed all of the statements inside of our program, and the program is almost ready to complete. The main function is still running, but since the function ends, that wrapper function, it implicitly returns, and when it returns, we remove main from the call stack and the program is finished. At this point, our Node process is closed. Now, this is a really basic example using the call stack. We went into the main function and we moved line by line through the program. Before we get into an async example, I want to go over one that is slightly more complex. This is example 2. Here, we start off by defining an add function. The add function takes arguments a and b, it adds them together, storing that in a variable called total, and it returns total. Down below, we add up 3 and 8, which is 11, storing it in the res variable, then we print out the response. And that's it. Nothing synchronous is happening. Once again, we just need the call stack. The first thing that happens shouldn't surprise you. We execute the main function. This starts the program you see right here. Then we go ahead and run the first statement, where we define the variable add. We're not actually executing the function, we're simply defining it.
Right here, that gets added on to the call stack, and we define add. The next line, line 7, this is where we call add, storing the return value on the response variable. When you call a function, it gets added on top of the call stack. When you return from a function, it gets removed from the call stack. Right here, we're calling a function, so we're going to add onto the call stack, and we're going to start executing that function. As we know, when we added main, we started executing main. When we add, we start executing add. The first line inside of add sets the total variable equal to a plus b, which would be 11. Then we return from the function using return total. That's the next statement. And when this runs, add gets removed. So return total finishes, add gets removed, and then we move on to the final line in the program, our console.log statement, where we print 11 to the screen. This is going to run. It's going to print 11 to the screen. It's going to finish. And now we're at the end of the main function, which gets removed from the stack when we implicitly return. And there we go. The second example of a program running through the V8 call stack. Now, so far, we haven't used Node APIs, the callback queue, or the event loop. The next example, we're going to use all 4. And right here, we have our async example exactly as we wrote it in the last video. In this one, we are going to be using the call stack. We'll also be using the Node APIs, the callback queue, and the event loop. All 4 of these are going to come into play for our asynchronous program. Now, things are going to start off as you might expect. The first thing that happens is we run the main function by adding it onto the call stack. This tells V8 to kick off the code over here on the left. The first statement is really simple, a console.log statement that prints starting app to the screen. That runs right away, and we move on to the second statement. The second statement is where things start to get interesting. This is a call to set timeout, which is indeed a Node API. It's not available inside of V8. It's something that Node gives us access to. When we call it, we're actually registering the event callback pair over here. The event is simply to wait 2 seconds, and the callback is the function we provided, that first argument. When we call set timeout, it gets registered right over here. And now this statement is going to finish up, the call stack is going to move on, and the set timeout is going to start counting down. Just because the set timeout is counting down, it doesn't mean the call stack can't continue to do its job. The call stack can only run one thing at a time, but we can have events waiting to get processed even when the call stack is executed. Now the next statement that runs is the other call to set timeout. Here, we register a set timeout callback function with a delay of 0 milliseconds, and the exact same thing happens. It's a Node API, it's going to get registered over here, essentially saying, hey, after 0 seconds, go ahead and execute this callback. That gets registered, and the call stack removes that statement. Now at this point, let's go ahead and assume that set timeout, the one that has a 0-second delay, finishes. When it finishes, it's not going to get executed right away. It's going to take that callback and move it down into the callback queue. The callback queue is all of the callback functions that are ready to get fired. Right here, we move the function down into the callback queue. Now the callback queue is where our callback functions are going to wait. They need to wait for the call stack to be empty. When the call stack is empty, we can run the first function. There's another function after it. We're going to have to wait for that first function to run before the second one does. And this is where the event loop comes into play. The event loop takes a look at the call stack. If the call stack is not empty, it doesn't do anything because it can't. There is nothing it can do. You can only run one thing at a time. If the call stack is empty, the event loop says, great, let's go ahead and see if there's anything to run. Right here, there is a callback function, but because we don't have an empty call stack, the event loop can't run it. So let's move on with the example. The next thing that happens is we run our console.log statement, which prints finishing up to the screen. This is the second thing that shows up in the terminal. This statement runs, our main function is complete, and it gets removed from the call stack. At this point, the event loop says, hey, I see that we have nothing in the call stack, and we do have something in the callback queue. So let's go ahead and run that callback function. It's going to take the callback and move it into the call stack. This means the function is executed. It's going to go ahead and run the first line, which is sitting right here on line 8, console.log, printing second set timeout to the screen. This is why second set timeout shows up after finishing up, because we can't run our callback until the call stack is complete. Since finishing up
is part of the main function, it's always going to run before second set timeout. After our second set timeout statement finishes, the function is going to implicitly return and callback will get removed from the call stack. At this point, there's nothing in the call stack and nothing in the callback queue, but there is still something in our Node APIs. We still have an event listener register. So the Node process is not yet complete. 2 seconds later, this event is going to fire and it's going to take that callback function and move it into the callback queue. It gets removed from the Node APIs and it gets added to the callback queue. At this point, the event loop is going to take a look at the call stack and see it's empty. Then it's going to take a quick look at the callback queue and see there is indeed something to run. What's it going to do? It's going to take that callback, add it onto the call stack, and start the process of executing it. This means we're going to run our once statement inside of callback. After that finishes, the callback function implicitly returns and our program is complete. This is exactly how our program ran. This illustrates how we're able to register our events using Node APIs and why when we use a set timeout of 0, the code doesn't run right away. It needs to go through the Node APIs and through the callback queue before it can ever execute on the call stack. Now, as I mentioned in the beginning of this video, the call stack, the Node APIs, the callback queue, and the event loop are pretty confusing topics. And a big reason they're confusing is because you never actually directly interact with them. They're happening behind the scenes. You're not calling the callback queue. You're not firing an event loop method to make these things work. This means you're not aware they exist until someone explains them to you. Now that you know a little bit about how our code executes behind the scenes, I want you to move on with the rest of the section and start creating that weather app that interacts with third-party APIs. When you're done with the weather app, come back and give this one a second viewing. These are topics that are really hard to grasp the first time around. By writing real asynchronous code, it's going to become a lot clearer how it works. Then when you come back and rewatch this, my hope is that it makes more sense. If you have any questions about how this works, please ask in the Q&A section. It's impossible to cover everything that happens, but I've tried to go through a few examples that illustrate how the call stack, Node APIs, the callback queue, and the event loop work. That is it for this one. I will see you next time where we start building out the weather application.
Jesus, finalmente. Bom. Isto aqui já não vou continuar. Estou todo morto. Deixa isto aqui. Oi. Então, tenho mais 30 merdas para fazer. Certo. Pronto, maltinho, eu vou bazar. Estou muito cansado. Estou cansado, portanto vou dormir. Vamos pôr na alheta. Então vá, tchau aí pessoal. Até amanhã e muito obrigado por estarem a ver a stream. Tchau, tchau.